In section 2.2.1, we talk about how to organize our data. So I'm going to do another video of doing a frequency table where we calculate bins or groups to put our data in. But initially in your homework, it's just going to have you actually go through and just list out the data and then count how many times each one occurs. So for example, on this problem, a teacher has students rate their heights in inches. The heights are as follows. The idea here would be to write down the heights and then count how many times each one occurs. Okay, so for example, the first height is 57 is our smallest data value. It occurs once. Right? Okay, then we do the same thing for 58. It occurs 1, 2, 3. And we continue to do that for each data value. So for example, there's 2 59s, 4 60s, 3 62s, and so on. So keep going on that, okay? I'm going to let you guys do that. Okay. A more convenient way to do a frequency table would be to create intervals. When we have this many data values, listing them all out, it doesn't really tell us a lot. What we're really looking for is, what is the data doing? Do most of the students have heights between 60 and 64 inches, between 55 and 65 inches? You know, where do they mostly occur? So if we look at these data values and we count them into these groups, we're trying to count how many heights or students are between 55 and 59 inches. So we come up here in our data and we actually count how many of them, or we can use the frequency table here. So we can see that 6 students are between 55 and 59 inches. So that's our frequency. Then we go back and count how many students are between 60 and 64 inches. Looks like 12. Between 65 and 69 is 5. And between 70 and 74 is 1. So doing a frequency table where we sometimes call these bins, it actually tells us a little bit more about our data. It tells us most of our students are between 60 and 64 inches. Right? Which is about, what is 60 inches? Divided by 12. It's about 5 foot, right? And 5 foot 4 inches. Most of our students are there. This makes sense? Oops, sorry. Okay. So the number of baseball pitchers throws per inning is recorded in the data below. Create a frequency table. Now, we could do bins here, or we could just do listing out our data numbers. So, for example, this is strikes per inning. And then our frequency. So our possible values here looks like 2, 3, 4, 5, 6, and 7. And the frequency, there were just one that had a 2, 1 for a 3, 2 for a 4, 2 for 6, 1 6, and 1 7. 2 4s and 2 5s. So here's our frequency table where we list every single value rather than grouping them together since we didn't have a lot of values. Make sense? Oops, I have a blank page. Sorry about that. Okay, now we can also do this for qualitative data. So what we dealt with so far was the quantitative data. So for the qualitative data, we would just list out our values and then count how many there are. So for example, a child notes the color of each car that passes her house. The data is listed below. Create a frequency table. We're going to list the possible colors she sees. There's black, blue, red, silver, white, and yellow, it looks like, right? Okay, and so then we just count in our data here how many of each one there is. So it looks like there's 2 blacks, 1 blue, 3 reds, 2 silvers, 3 whites, and 1 yellow. And we have a frequency table. So what we'll do in the next section is you could do a bar chart. We'll do that in one of the sections where you do a bar chart of this data, or you could actually do a pie chart or a circle graph. And this is just part of descriptive statistics, where we're describing the sample data set that we've collected. Okay, now in this problem, the number of hours 70 college students work per week at their summer jobs are recorded in the frequency table below. Using the given column, find the relative frequencies and round to the nearest hundredth. Okay, so how do we find relative frequency? We're going to add up. Okay, so this is telling us that 2 college students work between 0 and 4 hours. 7 college students work between 5 to 9 hours. 11 college students work from 10 to 14 hours, etc. So the total number of college students, it tells us, is 70. Oops. But had it not told us that, okay, we could add our frequency and they should total 70. This is lowercase n, or our sample size. Okay, so to calculate the relative frequency, we're going to take the frequency of each class and divide it by our sample size. So we take 2 divided by 70, we get 0.028571426, or something like that. It says to round to the nearest hundredth, so that would be 0.03. Make sense? So for the second one, we do 7 divided by 70, whoops, which would be 0.10, right? This one we do 11 divided by 70. Okay, you got the idea? That's how we calculate relative frequencies. Okay, so first we'd have to calculate a frequency table. On this problem, a group of friends count the number of letters in their names given by the data below. Construct a relative frequency table of the data. So you do have to start off with calculating the frequency table first and then the relative frequency. All right, in this last one, we want to talk about cumulative frequency. So, or this one's cumulative relative frequency. Cumulative frequency, let's just say I have another column here, just cumulative frequency. Okay, cumulative is like your cumulative GPA. You add the values up. So this is looking at the number of hours children slept each night. So it's telling us 2 children slept between 0 and 3 hours. So the cumulative frequency is how many children slept less than 3 hours. Well, clearly it's just 2 here. For our second group, it would be how many students slept less than 7 hours. So we have to add these first 2 together. So it would be 15. So now we want cumulative frequency, the number of children who slept less than 11 hours. So we'd add all 3 of these together, or we'd add the 27 to the 15, which would give us 42. And then, of course, the last one, number of cumulative less than 15, is everything added together, or all 50 children. Make sense? So for cumulative relative frequency, we're going to do the same thing. The first one is exactly the first class. The second group, we're going to add these together. And then we're going to add these together. And then we add them all together. And cumulative relative frequency, your last number should always be 1. Make sense? Okay, now relative frequencies also, they're as a decimal, but you can think of them as percents. Okay? So, for example here, what percentage of children sleep more than 8 hours on each night? Okay? So this is 8 to 11, this is 12 to 15. So it's really these 2 groups here that we're looking at. Right? So if we add those 2 together, we get 0.7. Or as a percent, 70% of children sleep more than 8 hours each night. Make sense? So what percentage of children sleep less than 7 hours each night? So less than 7. Okay, we're going to add these two together. Or we could use the cumulative frequency here. So 30%. Make sense? Okay, now in this last one, it's going to ask you, researchers count the number of children in each household in a neighborhood. Using the data, answer the questions in the following table. Okay, so in this frequency table, we have the number of children here, so we don't have a group, and then we have the frequency. So this is saying the households, there are 11 households that have 0 children. Right? There are 6 households that have 1, 12 households that have 2, 14 households that have 3, 7 households that have 4, and 5 households that have more than 5. Now the relative, how did we calculate that relative frequency? Remember, we add up to get our sample size here. So how many households did we look at? Let's go ahead and add those up. I'll do it with you. So we do 11 plus 6 plus 12 plus 14 plus 7 plus 5. So we get 55. N is 55. So to get the relative frequency, we take 11 divided by 55. So we got this by doing 11 divided by 55. Make sense? And we did the same thing for everything else. So now remember, the cumulative frequency, you're starting with the first one and then you're adding the 0.1. So 0.20 plus 0.11, we got 0.31. Now we need to add, for this cumulative frequency, these three together. So we take our 0.31 plus 0.22. We get 0.53. Make sense? Okay, so we wrote in the middle. What percentage of families have 3 or more children? Okay, so 3 or more would include this one, right? And we want percentages, so we want these 3 added together. So we have 0.25 plus 0.13 plus 0.09. Make sense? Or 0.47, which is 47%. Okay? Why don't you guys do, what percentage of families have 1 or 2 children?